Hey there, welcome to another Toolbox Tech Talk. Yeah, it's Sunday again. It's 2 o'clock here on the eastern seaboard, down here in rainy old Melbourne actually. So, welcome everyone. It's good to have you back on the show again. And look, I've just got to do my usual intros. So, I like to acknowledge the traditional owners of the land from which I'm coming from, which is the Yarra Valley. That's the Wurundjeri people. They've been here for basically forever. So, just acknowledge their traditional ownership of this land. But also, I like to reflect on the land I come from, which is Aotearoa or New Zealand, and the iwi people of Wellington, which is Whanganui Atara. So that's kind of my roots. But today's guest is actually running late. So today's guest is Jeremy Hunt from the Northern Territory, from Sunoxy. I'm not sure how you say his company name actually, but while he's getting ready, because he had to take his kids somewhere, I'm going to do a little bit of a filler. So, oh my God, he's just popped up in the green room. Talk about good timing there, Jeremy. Give us the thumbs up if you're really ready. You might, yeah, you are. Good. Okay. So I'll just bring you straight on board. Hey.
How are you? Sorry about that.
You're a real pro. That was right to the minute. That was fabulous.
Yeah, kids' events on Sundays. It was my middle daughter's gymnastics competition and football sign-on day for my youngest. So from one event to another, but anyway.
Well, that's really great to hear because, us Melbourne lockdown to 6.0, kids events just mean stay at home. My kids really miss their sport, so you're lucky. That sounds great.
Yeah. No, it was good. So they enjoy it, so they're out and about, and it keeps them out of the house for a few hours.
I guess that's been kind of one of the sort of advantages you've experienced being in the Northern Territory is your isolation and not being very affected by COVID.
Definitely the isolation has a geo, I suppose, factor in it. Our distance from everywhere, and I mean, someone said the other day we're a relatively compliant population, but I wouldn't say that. It's probably the last frontier. We don't have a lot of rules that you've got down there, but I would say distance from everywhere has been our saving grace a lot of the time. Yeah.
I don't know if you know the ABC comedian, Jimmy. He's done some pretty fun interpretations of the different states. In the Northern Territories, he's always sort of got a beer in one hand and it's going, yes, a 2-day bender, every time there's noise of a lockdown.
Yeah, well, there was a sandbar beach party yesterday. So, that's out in the middle of Darwin Harbour. There is crocs in the harbour. There's also about 50 croc traps, and they pull about 300 a year out. But it didn't stop the party goers, getting a barge, pushing a DJ set up onto it, and about 100 boats and 1,000 people having a party on a sandbar that appears, on the very low tides. The weekend, last weekend was the annual beer can regatta where you build a boat out of beer cans and then, have a race with it. So, yeah, it's not far from the truth where people do enjoy a tipple up this way. Yeah.
And is the Darwin water skiing club still got a picture of a croc on skis? Is that the mascot?
Yeah, I can't remember seeing that at the bar by the water, but I guess that's somewhere in their memorabilia. Yeah.
You certainly wouldn't want to fall off too often, so it's an incentive to be good, to stay up there.
Yeah, exactly.
And don't hit any big lumpy logs that are just waiting in front of you. Yeah.
Log holes, yeah.
Yeah. Oh, well, look, I did forget one thing, which was to ask you how to pronounce your company's name.
Sunoxy. Yeah. So it is a new company. My first company, Country Solar NT, has been sold, and I didn't go with it this time. But I started a new business, Sunoxy. So if you like, it's sun oxygen or the sun and a bit of an oxymoron. We love it, but it does crucify your skin up this way. So yeah. So
Cool.
sun. Yeah.
I got that one sorted now. I was just wondering whether it was kind of a clever one of those, Sunoxy or something, the X becomes a Z, but no,
Yeah.
Sunoxy, oxymoron, got it. Easy to remember.
It is a bit funny up this way. We've got a large Greek population, and one of the guys that he's done a few installs for me, he's of Greek heritage, and he said, "Where did your name come from, Jeremy?" And I'm like, "Look, I just sort of made it up, with a few euphemisms, and he goes, because the oxy in Greek means no, so your name actually means no sun." I'm like, I'm an oldie. Thank God I'm not Greek.
Oh,
a bit of humour there. So
that's interesting. Yeah, sun. Oh no.
No sun. Are you sure you're in the right business? Yeah.
Maybe you should go into the sun hat business for that name. Yep.
Yeah.
No sun on me. Hey, so it's a good segue to how I usually like to start these talks, is to learn a bit about my guest and their solar journey. And we did have a chat before the show earlier this week, and you gave me some heads up on your history. But let's run through it. How did you get started in solar?
I suppose my first touch of solar was when I was still at BHP up in the Pilbara. I grew up in that town in the town of Port Hedland. Port Hedland's the port for where the iron ore comes from. The iron ore is from 400 kilometres inland, and all of that rail has signals all the way along it, signalling and whatnot. And there's certainly no power along there, so there's a lot of small off-grid systems and 48-volt signalling and boom gates and whatnot, spanning 400 kilometres into the bush, essentially. So that was probably my first touch of it. That was back in maybe 1998, 99, and then a long period passed, and I had moved to Darwin on a permanent basis, and I went and visited a mate in Townsville, and he was doing it, installing back then 2 kilowatt systems on the side of his job at Ubulu and BHP, and I was looking for something to do on my days off. I was working, 5 days on, 5 days off shift, and on my off days you spent either too much time fishing or golfing, and it doesn't sound too bad, but you spend all your money, and so everyone sort of has a side gig, and so I started, after that trip, I thought, well, then, this is something that I can utilise my skills, and, I didn't really know a great deal about it. I knew people put solar on caravans, and there was electric gates with solar panels on them, and certainly the train stuff, but it was just supposed to be a side gig, and the first systems I was trying to sell were 180 watt BP solar panels for $16,000 with a 14-year return on investment.
Wow. That's really, it's amazing when you think about it now, where we've come from. And you weren't ripping people off. That was the cost. That was really the price. Yeah. That's pretty amazing. Hey, before we go on, just go back a bit there. So you started with doing signalling and power systems for, points on train lines and such. I mean, it really is the story of solar in Australia, is remote area applications like telecommunication and rail. And so, a lot of people way back in the 70s and 80s got their start in that area, because that's where it really was needed, because there was no infrastructure, generators aren't that reliable. You certainly wouldn't want to leave one out in the middle of nowhere. It's a pretty common story I'm hearing from people. They started with, just remote comms.
Yeah, and the reliability of it was great. They just kept going and going and going, and there was a maintenance program to go and top up the water levels and all the batteries and check all the system was charging. But the reliability of it was really good, and companies like BHP, I suppose, in effect, drove down the cost of solar, because they're the ones that were buying it. Them and your Telstras and whatnot that were out there developing panels and buying the IP and making their own and pushing it along in the early days. So, yeah.
Yeah, I mean, they were BP Solar, basically, so they were a major player in the Australian market, certainly, in manufacturing as well. So, that was really great. But then they pulled up stumps and said, "No, the future's not solar. It's going to be oil." Huh? Oh, well.
When I built my first website, I had a price list from RFI, and I listed on there, BP solar panels, and a local competitor up here. They called me into their office and read me the riot act that they were the only company up here that could sell BP solar because they were the Northern Territory registered agent. I said, yeah, but RFI have given me that registered agent status, so I can sell it and buy it through them. I'm like, why would I buy it through you? It's like, and so that was a funny introduction to competitive nature of it up this way.
Gosh, the old exclusivity clauses, which are kind of phony often. Do you know the story about how RFI got to be BP Solar's sort of main distributor?
No.
It was just an accident. RFI, you may know this, is really a radio business, so it's all about communication equipment. And part of that was to have some solar panels to power communication equipment. So they sold a few solar panels. They sold a few, mostly BP. And BP Solar saw that this large player who'd been around for a long time was buying quite a lot of the panels, and go, well, maybe you guys would like to be our main distributor. And so it just gave it to them. They weren't even bidding for it or anything. So,
nice. Falling into the space.
Yeah. So that brings you up to those bargain basement prices of $16,000 for a 2 kilowatt system, and was that after the $8,000 rebate?
Yeah, it certainly was. Yeah, I think I sold two. After I became accredited electrical contractor and did all those courses, and I sold two systems, and then all of a sudden this call come out of the blue, and I found myself out in remote Indigenous communities installing 50 and 30 kilowatt systems for the Solar for Schools program, on my days off. So that really thrilled my wife, and we had a 1-year-old daughter by then, and another one coming along, and so I was no longer fishing and golfing on my days off. I was disappearing out bush, working 5 days flat out on a roof, and then coming home and working 5, 12-hour shifts in a row. So she almost lost me for a few months there. And then, I suppose that there was a change of government up here. When I started solar, and the long paybacks were expensive equipment, plus electricity rates were 17 cents a watt back then, kilowatt hour, sorry. And but the change in government basically brought in a 30% tariff increase, and couple that with the decreasing cost in panels, and that was a game changer. All of a sudden it was 6-7 years payback on systems, and the phone wouldn't stop ringing. I worked those two jobs, so on shift and early days country solar, for about a year, until it wasn't manageable anymore, and I was no longer doing 3 days off, on my days off, 3 days working on the roofs and whatnot. 5 days. I was doing 2 or 3 to manage that, but my client list was getting longer, so I made the hard decision to throw in the steady job on shift and go full time with solar and hire people and get a workshop and all of those joys.
Hey, we've got a question come in. What I'll do, I'll pop them up on the screen, but just like to shout out to everyone. Please feel free to ask some questions in the chat. Even just share the love and give us a thumbs up or whatever. It's really appreciated. So Ray's got a question for you, which I think he means Port Hedland, the new solar system. He wants us what you think of it. I don't know if you've seen it.
I hadn't heard of it. My mum was a town councillor there for about 8 years, and she did mention that they were trying to do it years and years ago, but it fell over because of the Horizon didn't have any buybacks with the generator, which I think was Apache Energy. Don't quote me on that name, but I wouldn't. Being from Hedland, there's still plenty of mates over there that own businesses, and we did try and sell them 30 kilowatt systems. And I remember having a conversation with Horizon. They were saying, if you put 30 kilowatts on and a cloud comes over, the network's going to fall over. It's like, come on, we used to have machines on BHP's mine sites, which were 5 megawatts in itself. You'd turn that on and the grid didn't crash with 5 meg going on and off all the time. but I think that's all changed now, and they've opened up that network for a lot of solar. So, but yeah, I hadn't heard that it had gone ahead. So yeah, news to me, Ray.
Yeah, well, thanks for that one, Ray. Like, I think way back in the day when they had the Remote Area Power Assistance Scheme, or RAPS, wrappers, it was eligible to sort of parts of the network which were disconnected from the main grid. So I think sort of parts of the northwest interconnector were eligible for RAP. So that meant you got some pretty healthy rebates, 50% of the total cost of the system, including batteries and everything but the generator.
Yeah. Yeah, my mum, still in Port Ellen, is just coming off her 10-year rebate. So that's 58 cents. So it's been pretty healthy for her to have that. So she got a 5 kilowatt system, 10 years ago now. It's done pretty well. So those Horizon tariffs are coming off certainly. And the RAPs, was that also when there was the 5 times multiplier because you were not on a grid? So
the 5 times multiplier, which got wound back rather rapidly, was on top of the STC rate. So you got a multiplier on your STCs, whereas RAPS was on the total cost of the installation of a system.
Yeah.
So that was quite an incentive for off-gridders, and certainly where I live here on an off-grid community, a lot of people took advantage of that because effectively, 50% rebate on batteries as well, and inverters, and not just your panels. So it really made it very affordable. But that scheme got chewed up pretty quickly in terms of the allocation in the budget, so it didn't last long.
Yeah, I bet a lot of people jumping on it.
So going back to the 2011-12 period when systems were costing that much, I imagine there was some extra hurdles for installing in the Northern Territory, rules around power and water and approvals, and you've even got the Building Note 81 structural requirements. All of that must have added a lot of cost.
Yeah, I suppose that's always been, a lot of the... Over the years up here, people would often compare our prices to every other state. It's always that friend of a friend at a barbecue conversation. Oh, my solar system won't cost this much, and mine costs this much. And we've got the same gear. Why does it cost so much? And those soft costs or compliance costs in the NT have often added up to an extra $2,000. And the first one was power and water. Early 2013 or 2012, I think it was. I installed a 6 kilowatt system on a house, and that was within their rules. But they quickly shut it down and said, no, anything over 2 kilowatt was by application. And of course, that swamped their system. It was just one person answering emails, and it was pretty soon evident that was not something that could be managed internally for themselves. So then they made a blanket rule of 4.5 kilowatts. And the other one, the Building Note 81, which you mentioned, that was probably one of the steepest learning curves. As I said the other day, I would have sat with 10 structural engineering companies, and just none of it made sense. Like, we know what they were trying to tell me, and they were trying to explain to me wind load code 1170 in half an hour. And I was just like, well, why do I need to know this? I don't understand this. And then I did meet a guy, and he just put it down in layman's terms, and then it had made sense then. And but then sort of making systems and processes to make that as fast as possible. Not only for me first of all to learn it, and then for me to train my office staff when I was going through that process of hiring them. So then we had to write systems, processes, and showing people. So one of the processes with that was, we would have to go and we'd get authority to access everyone's building file, and so we would trudge along, email through all these building access requirements once a customer had signed up with us, and then we would go to the building advisory branch, and they would, it wasn't digitized back then. Everything was a paper copy. And so we would get customers' building files, and we'd be looking at houses and going, I need this elevation, I need this truss plan, I need this roof plan, and
wow.
And we would put that together in a document pack with where we think the solar panels would go. Early days it was red pen, and then we made layouts in PDF Editor or PDF Pro, and we would overlay them on top of the building plans, try and get it to size. And then, God, Nearmaps was a saviour when it did come along, because we could just sort of overlay that, add that as a design as construct, basically, and then pass that on to the engineers to do their calculations. But we would be looking at building files for pre-Cyclone Tracy houses, and there'd be nothing in them. There'd be a sewage and drainage plan and a photo with someone in their stubbies and a singlet out the front of the house with the lot number, and it was like from 1975, and you'd be like, that's the building file I'm dealing with.
So tell me, do you still have to go through that rigmarole of getting plans, even if they're digital? Do you still have? Yeah, you still have to go through that process.
Now they'll digitise a lot of those, and so you'd still send through an authority to access records, but you would get an email back saying, here's this customer's building record, and effectively you can see everything that's been approved or modified to that house, if it's on file. And so, you collect that, you provide your Nearmap design or pylon or solar CRM, and supply that to the engineer, and they would do their calculations, supply you with a building permit, and within that building permit as well is the testing of the panels. As we all know, not all products are made equal, and some don't make the grade up here. Typically in a Region C, and this is things that you didn't know you needed to know when you became a solar electrician, but the Region C, most roofs on a house are about 4.5 kPa of pull-out strength, or what wind pressure does it take to keep the roof on the house, if you like, because cyclones and high wind events have the factor where they're trying to pull things apart. So if you look at a house in the north of Australia, or most, there's more screws along the ridge line and the gutter line, because that's where you get your highest wind events happening. So wind hits it and tends to push off it, not in the middle of the roof, which is why you get those lower wind coefficients in 1170 in the middle. But going back to the products, what we've seen a lot of over the years, and in early days it was fine. Panels had 50 mil frames, and then that went to 45, 40. But now with 30, 35 mil frames, it moved down from 1.8 millimeter aluminium extrusion to 1.2. A lot of those panels that we see get tested up here are barely usable on a single story house in the tropics. And the funny thing, you guys are getting, if you're out in the Dandenongs, you got some of those strong wind events, like just this winter gone. So you would have seen some of those structural forces at play, and more than likely some of those panels would have been put under those pressures as well.
Yeah, I think we peaked over 110K or something like that. So I'm not quite sure what that relates to. The KPA depends on the pitch and where on the roof you measure it. But they're pretty strong.
Yeah.
Just a point on there. So I like what you said about pulling apart a structure. Like, a lot of people kind of think of the wind blowing things off, like pushing them down and over. But actually, it's the same force that makes a plane fly, which is that air passing across a surface creates a low pressure zone, which lifts the plane off the ground. And so you've got this low pressure zone forming on the roof of a house, which is the solar panels on the roof, and that's trying to suck them off.
Yeah, so and that's exactly it. It's just trying to pull it apart. So early days when panels were strong, like we did some pretty cool testing. We had a bit of a test rig, and one, we tested railing systems, because there's a system up here called the Deem to Comply, and if you want to spend $50,000 and make a submission and waste 12 months, then you could have your product put on that Deem to Comply. But a lot of the time, we didn't have the money to spend on that, so we would do testing ourselves. And one time we tested a racking manufacturer, and we basically put 4 pallets of panels on a framing system, to see when it would pull out or break. It didn't, so the engineers were happy with that. If you like, there was a strain gauge on there, and that told them, the strength of that rail. There's another time there's a NATA window testing facility up here where basically it's a box that they can pressurise to about 16 kPa. We built a frame which we put a solar panel inside of, which we put inside this window testing box. This facility in Darwin tested windows for high-rise buildings for the same wind load code. So in a high-rise building, the higher up you go, the thicker the glass gets because of that same forces and pressure. And so we pushed we made a panel go to about 14 kPa without blowing out of the frame. So that was pretty good. We had people from the building advisory along, and that satisfied all our engineers, and left us alone for another year while they signed our jobs off. And then products got thinner and smaller, and we had to. That was quite a costly exercise. So we had to find ways to test products because they were constantly changing, cheaper and faster. Now there's a fella in Darwin who I put solar on his house. He's a retired structural engineer, and he does a lot of testing of panels. He does it for a bit of fun, and he's retired, but he does earn a bit of a quid out of it as well. It's interesting talking to Simon and seeing the results and what works and what doesn't, and they're pretty honest with the manufacturers as well about where they see the flaws. There was one solar panel which didn't test that well, and it came down to the earthing hole in the middle of the short side of the frame, and I think they got another 2 or 3 kPa strength in it by moving that earthing hole from the middle to the corner, and something so simple, and all of a sudden you've got 2 or 3 more kPa strength in your panel. So it's that's been a learning curve and constant learning curve because products are always changing.
So I guess a lot of installers who are listening to this will be wondering why you have to test panels. Like, surely you just get one off the CEC list and go, she's good to go. Why is that not the case?
Essentially, it comes down to the engineers. So if you're running a solar business, then you've got products and public liability. Engineers have the same, and so if they're signing off on yes, this product will stay on that roof in a high wind event, then they've got products and public liability as well. And so they want to be sure that what they're signing off on is accurate. And until that building node 81 changes or the rules change up here, then essentially everyone has to comply.
So basically, let's take residential jobs, for instance. You're getting a structural engineer to sign off on every resi job. Yep. Wow. Yep. And what does that cost?
Anywhere from $880 to $1,100. So that's a soft cost that the customer has to pay. And how efficient you deal with it in your office is, I suppose, whether you add an admin fee to that or not.
And you mentioned when we had a chat before the show that you sometimes do testing on panels for larger projects. Now, is that to satisfy the engineers or satisfy yourself or the customer?
Yeah, all parties. If a panel's been tested at 800 or 1200 millimeters, which will be your typical framing system on a roof, or where the purlins are going, purlins or battens, then that would be the standard test. But not all sheds or structures are built like that, and so if a panel has just scraped through with testing, then the engineer may want to test in the different configuration to basically sign off or confirm that the panel can go at 700 or 600 clamping zones. And bear in mind, we're only talking about the localized testing and sign off here. We're not talking about compliance with manufacturers' warranties. If you clamp that panel at 600, does the warranty still comply? So that's a separate subject altogether that you usually take up with the manufacturer. And so, they can basically ask you to test in different configurations. A large project that I am working on now, we had to, the client wants a megawatt on the roof, and in a normal portrait configuration, we were only getting to 830. So I flipped a good portion of the panels to landscape, and flipping them to landscape means you've got to use 3 or sometimes 4 rails in Darwin.
Wow.
Yeah. So there's a time and material cost in that, and but then that meant that we had to retest those panels to meet that configuration. So 3 or 4 rails. So if it's 3 rails, it would be 550 centres clamping, and some of those products that we tested actually tested worse because there's as you put pressure on the back of the panel, there's a deflection in the glass, and we basically stiffened it, and so then the frame was buckling. And so those panels were deemed not suitable. And for larger projects as well, there might be a desire from the client or from the engineers to batch test the actual product that's going on the roof. Not a sample that was supplied 6 months ago, and so that they might want to just batch test just to know that what they're signing off on, especially if it's a significant project and everyone's public liabilities are, on the table if something goes wrong. So, yeah.
I'm just curious what the roof types are like. I mean, obviously, resi would still be corrugated iron a lot, but what about commercial? Are you looking at Cliplock, long-run steel? Is that pretty common?
Yeah. Did a job last year while still at Country Solar. It was 1.12 meg, and the roof sheets there were rolled Cliplock, and they were rolled on site. And they were 32 metres in length, those sheets. And so the client, very particular about his roof, he was, to say the least. So there was not one penetration on the roof, and that's the way we needed to leave it. And so this was 1.12 megawatts with Cliplock clamps, essentially. And the configuration there was, so hit 2, miss 1. So every 2 ribs, we would put a clamp, miss 1, and then 1, and then miss 1 and go again, hit 2, miss 1. So I think it was about 36,000 Cliplock clamps.
Oh, wow. That's insane.
Hey, a lot of sore knees, yeah.
I don't know if you've seen on my YouTube channel, but actually we do some testing of different products, and recently had an American company, S5, provide us with their rail-less system. I don't know if you're familiar with S5.
I've used their clamps a few times up this way. Another product that we had to basically hang a weight off on a piece of Cliplock with a strain gauge to satisfy the engineers. Mm-hmm. So S5 might, and I think it's Mac Fasteners might have done all their own testing in Australia, but then being Darwin, we've got to do additional to satisfy the needs up this way. So yeah. But I didn't know they had a railless system, unless they're the clamps you're talking about.
Yeah, so they've got a range of clamp systems. I've used the Corro bracket on corrugated iron, which is railless, and the ones designed for Cliplock as well. I think they're called K-type. And yeah, they basically have a large stainless steel disc with sharp points in it that that the panel is pierced onto the frame with, so that's the bonding, the earth bonding. But because of our regs in Australia and New Zealand for continuous earthing of a PV array, you have to additionally run continuous earth all around the array, so all the panels are bonded together. But it does mean there's no rails at all. So putting in, we just did a little 10 kilowatt system here for a test, and it was 3 shoe boxes of clamps. That's all we took to site. So it's very, very minimal in terms of materials, and the clamps are super strong. So yeah, I'm sure they'd meet those pull-out tests.
Yeah, that might be something to look at.
I'll link it after the show. I can link stuff up here it's probably on your side of the screen, but up there to that particular product. So I've done a little bit of a show and tell video and unboxing, and also some install stuff with it. So yeah, that's kind of cool. Wow, so I'm really getting a feeling that you guys are kind of like the cutting edge of quality because you have to be, because of the engineering requirements and the permitting, and like just the fact that you've got to go and cut the plans for the building for a residential install, which is over here on the eastern seaboard, it's like look at it from space and we can do it.
Yeah, so site inspections are a must up here.
Yeah.
Yeah, not only to just look at the layout on the roof, confirm what you've done in the office, but just to know what you're looking at roof wise. With older pre-Cyclone Tracy houses as well, a lot of the time the engineers will want to see the internals of the roof. They weren't built. If they did survive that, then a lot of the trusses aren't nailed down, and sometimes extra work needs to happen. So. It's good on the product sense. It does mean that largely we've avoided inferior class tier 2, if you like to use that term, or tier 3 panels coming up this way, because they just couldn't get through that initial engineering requirement. So it has saved us. The downfall for that is a lot of products do travel the 3,000 or 4,000 kilometres via road, and that tends to be not kind on solar panels that make that journey. You don't see that in the first 5 years, but certainly after that they do appear. My own procurement policy for years has been to only or to bring into Darwin from straight through the port, and so wholesalers that supply direct into Darwin are the ones that I've tended to favour. Not saying that I haven't brought panels up on a truck, but it's been a last resort, if you like. Yeah.
Right. Hey, we've got another question from Ray. So this one is about building integrated PV. So have you done the sunken panel? I think what he means is there's some designs with like a pan that goes into the roof. So the roof is the solar panel. There's not a separate roof and separate panel. Are they at all possible in the Northern Territories?
No, so I haven't done any myself. I have seen, if you like, a greenhouse where someone built their own BIPV, but it was just out of normal solar panels, a lot of tech screws. But I've done it in solar car parks where the PV panels are the roof. But nothing building integrated, no awnings or anything like that either. Yeah.
What about carports and stuff? I suppose they've still got a lot of engineering as well.
Yeah. Same. A lot more engineering actually. With Country Solar, we did 3 solar car parks. We actually did the first Schletter concreteless carport that we were told later by Schletter worldwide. So we one of our structural engineers had advised us of this pretty cool thing, which was early days back then, called Surefoot. So we got our local structural engineers, Surefoot, Schletter, and I think there was someone else that we got involved. But and we basically designed solar car parks with the use of Surefoot, and the reason being is a lot of people drive 4-wheel drives up here, and if we were, taking away significant portions of this car park space with these concrete bollards, then called concrete piers, then the structure wouldn't be so suitable, or there would be damage to it. So, we managed to come up with a solution for that, and it worked pretty well. And it's certainly the customer was happy, and Schletter came back to us later on and said, I think that's the first time someone's done that without concrete. So. Yeah.
These are the ones where you hammer in some long poles into the ground through sort of surface mount bracket.
Yeah. So they it works like a tree root system where you've got lots of poles, and those poles could be 1.2 meters into the ground in embedment, and basically then the pulling strength doesn't favour any side, because they're all working against each other, and.
I've actually got them here. Look, here we go.
Yep. So, they're the small 4-pillar units. The ones that we've used have up to 10 poles going through them.
Yeah, I think there's a diagram for a small one with 4 poles being rammed through. So you're not doing much excavation really, just a few hundred mil down.
Yeah, yeah, exactly. Yeah,
Wow, that's cool. And you can do big structures. There's a whole house. That's one with 8, I think. Yeah. Oh no, 10. That's
yeah.
a lot of pins. Yep. Cool. Oh, thanks for pointing that one out. Yeah, I've seen the similar products used fencing. It's not. I'm not sure if it's surefoot, but we've got them here on our land. It makes for easy to remove too. You don't have a big lump of concrete in the ground left behind.
Yeah, yep, no, it does, and yeah, less environmental footprint as well. If I'd had quoted some off-grid systems with them out in national park or out on country. Basically, you eliminate the need to transport concrete, and that can be, if you've got to go and do an environmental project management plan, then that's usually a significant consideration. How do you dispose of the waste? How are you going to manage that? And not to mention, if you're trying to transport concrete through the bush, it fast escalates into $500, $600, $700 a cubic metre. So there's a significant cost saving there. Yeah.
Yeah. If you've got pretty short range with a truck with a mixer on the back.
Exactly.
Hey, a couple more questions. So Paul's asking, what's the most common panels in Darwin? I don't know if that's something you can answer.
In your entry level Chinese manufacturers, JA, Jinko, Trina, Canadian, and then your premium panels, LG, REC, Hyundai, SunPower, they all get probably equal and fair representation up this way. And then I doubt that there's much deviation away from those. Yeah.
Cool. And another one from Ray. Ray's a serial question asker here. Good on you, Ray. He's on every Sunday. So he asks, have you had more sales of solar and batteries since the new NT government incentives, or has he dropped off on sales of solar since no rebate for just solar? Is that true even?
I mean, the rebate changed last year. It had to change. We were the last jurisdiction with a one-to-one incentive, and so rightfully so. I mean, the Parramatta, Jakarta Territory Generation up here are all government entities still. So the government is the 100% shareholder in there. If you're a government looking to get a dividend from your entities, then you need to pull back some of those incentives, and I think 10 years of them has certainly been long enough. Yes, sales did drop off. There was, like any other jurisdiction that's gone through that phase, there was a big rise in those last week rush or that last 24 hours, and then a fall on the other side as everyone worked through those sales. But I would say the sales are pretty steady, returning now, where people have worked out that it's still worth my time. The current government has kept the battery, the $6,000 battery rebate available. Initially they said it was 250 or 300 systems. They extended that, and now they've extended it again. So that's been pretty good for battery uptake in the NT. Regular sales for Grid Connect Solar without battery are probably still steady. So I wouldn't say that they're returning to the previous pre-one-to-one tariff numbers, but they're steady.
Right. Okay. So, is batteries part of your business? Is that what we just?
Yeah. Yep. So, I'm battery accredited. Sold and installed a few off-grid accredited as well. So, yeah, done a few of those. It's a bit of a, are they worth it at the moment? We have no different change in tariffs up here. So there's no off-peak, on-peak. It's basically flat rate. So it is an emotional. It's not a good investment in my mind. So it's an emotional investment. You're making use of the current tariffs because you're never going to get a battery that cheap unless you win it. But yeah, so over time, though, those electricity tariffs I think will change, and those people will be ready for it. If you do install a battery up here, you do move from the one-to-one tariff to the lower feed-in, but that's it doesn't seem to be a deterrent for people at the moment. So people are more interested in getting hold of that $6,000
Yeah.
reduction.
Look, I mentioned because Darwin, maybe because of Cyclone Tracy, has a relatively modern electrical infrastructure compared to some of the older states, and therefore probably a more reliable one. Would that be true? So less blackouts?
Probably in the Darwin area, the rural area of Darwin, which is not too far away. They have longer lines like any other rural area, so they do suffer a bit
Yep.
from outages, not long duration outages, but still outages. There has been a few complete blackouts of the grid over the years, where if it's this time of year, God, it's hard to sleep at night when it's 32 degrees and 90% humidity and no fans running. But I think that's probably a driver for a lot of people. 10 years ago there was quite a few blackouts and regular occurrence. Come the wet season when you do get storms roll through. So a lot of people do. That is a motivating factor. Is reliable power essentially, through cyclone or storm season. Yeah.
Hey, I can see in the background your house looks like it's got quite a lot of louvers and passively ventilated with ceiling fans. I guess you're in some ways but protected from blackouts in that if you don't need aircon, you can survive without it.
Yeah. This is a Tropo architect house design, so it is passively cooled. A lot of louvers, everything opens up in every direction to get to whatever the prevailing wind is at the time. It still does have air cons, but they're probably not used as much as those modern design concrete houses that we see nowadays. The fans and the high ceiling space dissipates heat faster, and then it's built from lightweight materials to get rid of the heat quicker. The fans are great. They're awesome. So
I think your house is the exact opposite of my house, and that's because of the climate. So my house has got 600 mil thick walls, straw bale, R30 insulation, double glazed, in slab heating, lots and lots of thermal mass. It's all about keeping it in, but in the tropical zone, it's the exact opposite. It's just let it go. Don't store it. Ventilate. And if you can avoid using electricity, like reverse air conditioning, to minimise your reliance on that, all the better. So it sounds like you've got a great house there for the climate.
Yeah, it's good. You probably saw my kids just up in the top window there.
No, I didn't actually. Actually, one of mine popped up behind me, but you didn't see them. I could just see them up the corner of my eye. He's peeking around the side of, saying, Dad, I want something, Yeah. Hey, I got a question for you about working in that climate zone. Like, I've been to Darwin and the Territories a few times as a tourist, and in the dry season, 36 degrees, and I could barely walk. And I'm thinking, how can anyone work in this heat?
Yeah. When I first started, and as I was saying before, I was doing it on my own in my days off. I gave myself heat stress, and I used to take 2 days to do a 5 kilowatt on my own. And I just cooked myself one day. It was so hot, and I was down at Mataranka, which is 400 k's from Darwin, and I had to go to Katherine the next day to scope out a solar for schools project. And I remember just falling asleep in the caravan park cabin with a thumping headache, dehydrated, lights off, eyes hurting, just going, what have I got myself into? And later on, that was a big driver for OH&S policies. So, as we got a lot of guys and we're doing significant projects, your actual efficiency and time allocation to jobs is probably 5 to 6 hours. In the dry season, you can have 3 guys finishing a residential job, but as soon as you start to move into the wet season, everything slows down. So you just because you start to lose a lot of fluid from yourself. And then you start making poor decisions because of dehydration. And so the rule of thumb that we had was, start early, finish early. We always tried to be off a roof by 12 o'clock, 1 o'clock.
Well, the rains come in the afternoon, don't they? So in the wet, so yeah.
So we would start early and try and get to the house as early as possible, as the client allowed. and so then you've done the bulk of the hot work in the morning, and it's still 90% humidity in that time in the morning, so you sweat a lot, but you're not in the baking sun then, and you're not dehydrated in the sun trying to catch up. And you can't, once you've lost those fluids, you can't really catch up straight away. It takes 24 hours. So there was a build-up. We call this time of year, mango madness, or build-up time of the year. It's where the rain hasn't come, the dry season's gone, 90% humidity, 36 degrees, and it's just hot. It's just really hot and humid, and everyone goes a little bit tropo, so they get the mango madness because it's mango flowering season, and the mango trees get picked. We had this wet season or build up a few years ago, and I reckon out of our work crew of 12, every second day we had someone else with heat stress. It was just that hot. We couldn't keep a workforce stable, and you're providing electrolytes for them, fluids. We had ice machines at work, so everyone leaves the workshop with 5 or 10 litres of water. It's gone, by the end of the day, so they've drunk it all, and then you're trying to, you've got the electrolyte replacing icy poles back at the workshop in the afternoon. But yeah, we still, it was just hard work on OH&S to keep everyone, and then that then plays into working on a roof at height, and that height safety, and making decisions when you're fatigued, if you like, so and then that's always been our driving factor, is try and get off the roof by lunchtime, midday. Doesn't matter if you're back at the workshop, you're back at the workshop in the shade, cleaning out utes, preparing for the next day, rehydrating, whatever it might be.
Even just handling your tools, they get so hot.
Yeah. So.
Wow. Yeah, it sounds pretty tough. Hey, we've got another question here. This is from Ben. So Ben asks, how do you find Darwin's grid voltage fluctuations with a voltage-dependent power reduction? Do you find pockets that are more susceptible than others? So for people who are not familiar with that VDPR, it's a new requirement which is baked into the new standard for inverters, by the way. So they have to kind of reduce their voltage as reduce their power and or inject more reactive power as the grid voltage rises. So how's that for Darwin?
In the rural area, it's pretty bad. There's a lot of older systems out there which have the hard shut off on the over voltage. So you end up with that sawtooth pattern of voltage rise, drop, voltage rise, drop. And then you've got these newer inverters, which, coupled with 5 and 10 acre blocks where there's a long skinny line in from the roadside, and then you've got a voltage reduction dependent power reduction inverter at the end of it. So you've got the sawtooth pattern on the street, and then you've got those inverters at the end of a skinny line, and so you are seeing quite an impact on people's productivity. I'm not too sure what the answer with that is. When I did speak to people in government when they brought out that we've had a series of schemes called the home improvement schemes up here, and the last one, which came about when COVID hit, I think it might have been. They kicked solar out of it. Solar have been a pretty big winner, and been basically a top 2 recipient of government money. And I think people in the government saw that as enough justification to kick it out. And one of my suggestions was, maybe don't kick it out, maybe have it as an item where people can upgrade their inverter to the new smarter inverters, and then that'll improve everyone's efficiency across the board. Not only that, the new inverters can meet any new standard that Power and Water bring in, potentially following suit with what South Australia have done. But I think it was maybe a bit too much knowledge for them, or a bit too much information and a bridge too far, so they kept it out. But certainly, there is quite a significant impact of that happening in the rural area where older inverters coupled with lots of PV and long skinny lines to people's premises.
Hey, this is a good chance for a public service announcement. Heads up, everyone, the 18th of December this year is when a lot of inverters will fall off the CEC approval list because they won't comply with the new test standard for inverters. That's ASNZS 4777 Part 2, 2020. So it had a 12-month adoption period, and that date comes up on the 18th of December. So if you happen to be holding stock of inverters that no longer will be, you can check it out on the CEC's website, by the way, what the expiry date on the certificates will be, but you won't be able to install them after that date. So I hope that's not news to you, Jeremy.
No, I'm all
good.
good.
That's good. Hey, a little bit of going back to the power quality of the grid. I remember when the Solar Cities program was running in Alice Springs, I think it was the casino got a very big system for its day put in, and they discovered it was turning off all the time. And initially blamed the installer, as they always do, and then they discovered it was because of the frequency variation on the Alice Springs grid. And it appeared that the power and water are actually controlling load somewhat by playing with the frequency.
Yeah, I think that's also a symptom of larger grids that are dependent on diesel gensets and basically spinning machines to make that inertia. So they can often suffer from those frequency variations, and it might happen really fast and really quick and be corrected. But yeah, I think I did read something about that years ago, that they were using it in that function, which is probably not, what it's supposed to be there for.
Yeah, it's not nice for your motors and stuff to have 48 hertz running through them, but yeah. I do grumble a little bit, get a bit hot. But I remember actually a acquaintance of mine was one of the installers from Melbourne actually working on it, and they were pulling their hair out trying to work out what the problem was. And it was also because it was such a narrow window most inverters had. It was only 0.2 of a hertz, and they switched off. So if you were 50.2 or 49.8, anything outside of that, off they'd go. There was no ramping down. But that's since changed, so it's not such a big problem.
That would have been a nightmare back. That would have been 2012 or 13 that system went in. It was like 150 kilowatts back in the day.
It's funny to think that was like an enormous system, 150 kilowatts. Like this is your standard factory job,
Yeah. You're less than 10 days on the roof now. They were probably there for 6 weeks.
I tell you what, I'm really over pictures of 100 kilowatt systems on Facebook. It's just a roof after a while. Yeah.
I don't think they win awards at the CEC anymore, do they?
Maybe they'll go the other way. Who's got the smallest system that makes the most, revenue or something? I don't know.
Not a bad category there. Maybe the solar cutters can do something like that. Most efficient, smaller system.
Tiny solar. Yeah. Hey, I'm just checking the time. I think we're coming to the top of the hour, which is kind of when I try to finish these chats. And look, it was great that you just rushed in from your kids' sporting event, got there on the dot. Thanks. I actually started typing all these notes, thinking, what am I going to talk about if he's late? No, I have to make up some rubbish. But yeah, it's been really interesting, hearing a bit about the life of an installer in the top end, and the challenges of heat and regulation, and the fact that it's driven quality for you and your business.
Yeah, and look, it should continue to, across the network up this way with all the installers. I think everyone's aware, of the conditions we work in. Not only is it hot, but come the wet season, the other night, it's not even wet season, we got 40 mil of rain in a few hours. So that's just common occurrence. So you're building your systems up this way to encounter a lot of water really fast is also something that people are used to up this way, because moisture just gets into everything. So yeah, I made some mistakes with that in the early days.
Actually, I just remembered I never got into talking about lightning, because really Darwin's the lightning capital of the world, I believe.
There's like 1 million strikes a year that get recorded across the top end. I had a bit of a fight with a manufacturer years ago. I won't mention any names. People that know me will know who I'm talking about. But and they basically brought up this lightning map and said, your product warranty is voided because there's been lightning within the area. And I'm like, what are you talking about? We get every wet season, there is 1 million strikes a year across the top end of Darwin, Northern Territory. Here's the reference source. Here's the Met Bureau's reference source. I said, so if you are selling your product into the Northern Territory and you knowingly know that, then you're knowingly selling your product without warranty. And, I said, we don't have this issue with this, and this product, so it's just yours. And, it was radio silence and the relationship fell apart.
Yeah, it's a pretty special area, protection from lightning.
Yeah. That was my rant for the day. That's it.
Indeed. All right. Well, I might just do my outro, but thanks very much. It's been great talking to you, Jeremy.
No worries. Thank you, Glenn.
All right. You can get back to the kids and have a cool drink.
They're in the pool now. Thanks.
Okay,
Thank
good.
You.
Lucky you. All right. I'll drop you in the green room. Okay. See ya. Wow. That was pretty impressive, hearing some of the challenges of working in the Territory. So, yeah, well done, Jeremy. Now, look, a couple of announcements before I go. I'm running another one of my battery standards crash courses. Just to clear up any confusion, it's not a CEC accreditation course. This is professional development. A lot of the people who do this course have already got their battery accreditation, but the battery standard, ASNZS 5139, is pretty complicated, and it's really it's a completely new standard. It's not just an update of an existing one. I'm on the committee that helped write it, so I know it pretty intimately, and I run these courses about every 6 weeks. So it's an online course. It's run via Zoom meetings, so you can talk to me, and we'll basically in a classroom online. The next one coming up is the 29th and 30th of September. It's running at 12:30 noon to 4:30 p.m. Australian Eastern Standard Time. It's recorded. And for generally about half the class don't even attend. They just watch the recordings, and I send them out the next day. So they're 4-hour sessions with a half-hour break in the middle for some food and drinks, and so you can keep your attention span going. And they're very interactive. I just encourage questions. In fact, people send them in before the course starts. So, yeah, if you're interested in doing that, look, I should actually bring up the link so you can see where it goes to. You can just go to solarquip.com and register for that course. Other things, too, is I do have a lot of free content online through my YouTube channel, which is Smart Energy Lab. So if you're bored on a Sunday or any day of the week and you want to learn some stuff, go to my YouTube channel. Just search for Smart Energy Lab. You'll find it there. I've even done a 13-part series on designing a solar and battery system. So that was done last year during COVID. Had plenty of time on my hands. And there's also a lot of product reveals where I talk about new products that come on the market. In fact, just the last few weeks, what have I had? I've had Sonnen Hybrid, S5's mounting system, Goodwe 10 kilowatt hybrid, the new SMAPI EV base charging system, building an Ingeteam 3-phase system using Pylontech batteries, Solaria all-black panels, which look amazing, Cleanergy's universal clamps, which we had a really fun day with the Cleanergy crew where we tried to break one by getting my four-wheel drive Troopy and another four-wheel drive and a chain and put the clamp in the middle, and we had all four wheels spinning on the four-wheel drives, and it didn't break straight away. It did break eventually. You're talking several tons of pull there. And yeah, also do a few bit of content for other people. So you might have seen me pop up on LinkedIn recently with Ria O'Hare from Greenbank, talking just about Up on the Roof, her program there. And watch out for Solar Quotes TV. They're actually going to do an interview with me this week, so that might come up in Humans of Solar, their little special. So there you go. That's what's been happening in my world, and I'm even occasionally on Twitter, so I don't know if you tweet a bit, but and also a few fun pics on Insta. So there's all my stuff. So that's it for today. Thanks for watching. See ya.